Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal Haikal bin Azman with metric number 2215307. So today basically I'm showing my lab on experiment 2, which is simulation on deflection. So basically I'm using Autodesk Inventor Professional 2024 and Autodesk Inventor Nastran to do the simulation on deflection. In this experiment, we will use cantilever beam as our simulation, and then we will put the force on the free end of our cantilever beam to see the deflection. So the first step is I will start a 2D sketching on a YZ plane. So I will choose a rectangle shape, and then I will sketch it with 25mm length and 25mm width. And then I will finish the sketching. Then I will go to the isometric view, and then after that I will use the extrude function to make the shape of cantilever beam three-dimensional. So I will write the distance about 250mm, and then I will put OK, and then we will go to the isometric view. So this is the basic shape of our cantilever beam. So in order to complete the simulation, we must use Autodesk Inventor Nastran. So I will go to the environment part and then click on the Autodesk Inventor Nastran to run it. So the first thing we need to do is to choose the materials. So I will choose material stainless steel from the material library. So we need to scroll down until we find the material stainless steel, then click OK, and then we must set the type of the material to be isotropic for the properties of the material to be constant throughout the process, and then click OK. So the next thing we need to do is generating the mesh line. So I will click on mesh setting and then generate mesh, and then from this we can see the mesh line are created on our cantilever beam. So the next thing is to apply the constraint on our cantilever beam. The function is to tell the software that the end of our cantilever beam is sticking to the wall. So I will click on the constraint function and then choose the fixed end, and then I will choose the rear surface of the cantilever beam, and then I will click OK. So from this we can see the constraint were created on this surface, and then I will go back to the isometric view. The next step is I will create a loads on the other end of our cantilever beam. So I will use the load function, and then I will put negative 500 Newton on the Y direction to make the forces go downward. And then I will choose the front surface of our cantilever beam. Then I will click OK. So from this, we can see the negative 500 Newton forces were applied to our cantilever beam. So after that, I will run the simulation. So before running it, we need to save the file first. So I will save it as simulation. And then we must wait a few minutes for the simulation to be run. So after a few minutes, we can see the simulation is complete, and we can see the cantilever beam will bend with the 500 Newton force. Besides, we also can animate our simulation for it to be moving. As an example, this is the moving animation of our cantilever beam. So we also can choose to see the displacement of our cantilever beam by clicking the displacement function, and we can do many more features such as strain, reaction force, and reaction moment. So lastly, this is my report from the cantilever beam bending simulation. So this is the content of my report. This is the original shape, and then assumption, and then model definition. That's all from me. Thank you.